Welcome back to ArmanisMath. Today we're going to discuss adding and subtracting rational expressions. Adding and subtracting rational expressions. The or difference of rational expressions. I can find the sum or difference of rational expressions. Help me with one word from the objective in the chat. If you could give me a word from the objective before we move on. Difference, rational expressions, rational, sum. Okay, there's too many of us here and I only see 4 or 5. I need to see more of you guys. Find. All right, so if you looked at adding fractions or subtracting fractions, just like the one that we're looking at here, we need to have something called the common denominator, right? So if I'm saying 1/2 plus 1/3, for example, I need to have a common denominator that is big enough to contain the 2 and the 3. What do you think is this common denominator for us here? The 6 is. And the 6 is a big enough container to contain perfectly 2 3s, right? Here's a 3 and another 3. And it's also perfectly enough to contain, without remainders, 3 2s. Here's a 2, here's another 2, another 2. So 2 and 2 and 2 fit perfectly enough in the 6. 3 and 3 perfectly fit enough in the, both of them fit in the 6 without no remainders. So now the question is, how do we make this look like a 6? How do I make this 2 look like a 6? What do you think I should do? I need to make the denominator look like 6. This is a 2. How do I make the 2 a 6? What do I need to do? I need to multiply by 3. If you multiply the bottom by 3, the denominator, you're going to multiply the top by 3 as well. Okay? And I also, by the same token, I make this 3 a 6 by multiplying it by 2. But if you multiply the denominator by 2, you're going to multiply the top also by 2. Numerator by 2. And in this case, I'm going to say 3 times 1, that's 3, divided by 6, plus I've got 2 divided by 6. Since I have a common denominator, I'm able to add these 2 fractions. So now I have only one big humongous denominator like this, which we have a 3 plus 2. And that's going to be a 5/6. Okay, I know that you guys know this by now. I know that. But we have to review this concept before we talk about similar concept when it comes to rational expressions. So this is fractions. Rational expressions are polynomials, as you said, in a fraction, but polynomials inside a fraction. Okay, so first thing first, you could have a rational expression with like denominators, meaning they are very nice enough and they just show you stuff that look exactly the same with the same, that has the same denominator. So for example, here's this one here. This one says add these 2 rational expressions. Why rational expressions? Well, because they have x's, they have variables. It's not just fraction, they're rational expressions. I notice here that we have the same denominator. We have the same denominator. Do you see that? It's exactly the same. So if I have the same denominator, then I'm actually ready to just add them up. I'm just going to add them up. Let me make this a little bit larger so you can see. So I'm just going to add them up. Well, this means I have one humongous denominator, x plus 4. I'm just going to add the top, x plus 5. That's all, since I have a common denominator already. I'm lucky because that was the case. Now, sometimes that's not the case, right? So in another example, this is not exactly the case. And this example has a little bit different. I mean, I shouldn't say different as much. It's not like perfectly done for us. We have to do just some tweaking to see what's going on there. So this one says add 2x plus 1 divided by x squared plus 3 plus 3x minus 8 divided by x times x plus 3. So my eyes has to be trained enough to see, can I get this to look like that? Well, let's see if I actually multiplied it out. Would that look like it? Yeah, would it look? I'm not sure. Let's take a look. So I'm going to go here and try to multiply it out. So I've got 2x plus 1 divided by x squared plus 3x plus, top stays the same, 3x minus 8 divided by, and this guy I'm going to actually multiply. I'm going to distribute this in hopes to get the same denominator. And it turns out to be, I was kind of right. This is x squared plus 3x. Oh, okay. That's not bad. So I found out that once I distributed this x into the parentheses, I'm facing the same denominator. And because you have the same denominator, what do you do? Can somebody tell me? What do you do if you have the same denominator? That's it. Myra is saying you just add, Armani. She's right. You just add the top. So this is 2x plus 1 plus 3x minus 8. All right. So how much would that be? 2x plus what? Obviously, I'm going to collect like terms, combine like terms. So this one and this one together, right? And also the 1 and these ones together, right? So let's do that. I've got 2x plus 3x. How much would that be? Help me out. How much would that be? 5x's, that's true. And what about 1 minus 8? That is negative 7. Guess what? We're done. That's it. That's this problem. This problem is finished. As simple as that. So we looked at identical denominators. We looked at kind of similar denominators, except with one tweak that we made it exactly look the same. Can we have different denominators? Yes, that's what's going to come up next. So stay tuned. Do not change the channel. Stay tuned. What is the sum of, they're wanting me to add this rational fraction to another rational fraction. They're asking me what is the sum of this. So I'm going to just put it the way it is. Thinking, if I could have this guy here to perhaps talk to this guy here, I would be lucky. It doesn't look like it's going to be the same. But for me to know what do I need to add for that common denominator, I have to basically find out what's inside here. We're asking what's the components here. What are the factors that make up this x squared minus 3x plus 2? What are the two factors or the parentheses that make up the x squared minus 1? Does anybody remember? We talked about this before. What would x squared minus 1 look like when you factor it? Does anybody know? X squared minus 1. So I'm going to take the first one, x squared minus 1. I want to find out what's here, what's inside here. What kind of parentheses, what kind of factors do I have here? What kind of factors do I have here? Hopefully they get something in common. If not, then I have to multiply by anything that is not in common. Okay, can somebody tell me? This is x squared minus 1. What does this remind you of? Come on, come on. You guys, we did a problem like this earlier. What does this remind you of? Does this is there a shortcut for this? Is there a shortcut for this? Alexia, Annabella, Andrea, Brian, David, Donovan. Don't wait for your friend to answer. You also need to answer. You need to participate. We talked about that. Participation. Shalom, Tatiana, Yurishi, Nick, and Olsen, and Maddie, and Lindsay. Okay, I like the word square. I like the word square. Right, that's true. This is something here being squared, right? Something here being squared. Minus another thing being squared. 1, by the way, 1 squared is 1, so don't forget that. There's something else being squared. So what's so I'm going to take Ryan's idea. It's difference of squares, obviously. You have something squared minus something else being squared. What's being squared here, you guys? Can you tell me? What's being squared to give you x squared? Think again. Don't rush it. What's being squared to give you x squared? That is true. X is being squared to give you x squared. What is being here to give? What's being squared to give you 1? What times itself gives you 1? 1. This is true. So basically, I could come up with x minus 1 and x plus 1. These are my factors for this dude here. So I'm going to take it and just replace it. So basically, I have x plus 3 divided by x plus 1, right? And x minus 1. That's the first fraction, plus the second one. Okay, the second one, I have to think. How do I factor out? Remember, you need to find out what's inside that. What's inside the x squared minus 3x plus 2. Do you guys know or remember how do you factor out quadratics? How do I factor this out? Here we go. You could use a diamond for this. So let's use a diamond. I've got x squared minus 3x plus 2. And can somebody tell me what's ABC to factor using the diamond? I'm using ABC. ABC. Multiple users are typing. That's I like that. You could use the chat. You could use the live stream comments. And give me some feedback here. A is equal to 1. Thank you there, Kiera. And B is equal to negative 3. And Kathleen, I see that. And C equals to Myra. I see that also, 2. And at the top of the diamond goes what? What goes at the top of the diamond? Or the big X? What goes at the top of the diamond? The A times C, or the AC, the air conditioning at the top. Ha 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 ha. Air conditioning at the top. So A times C is at the top here. 1 times 2 is 2. And the B, the bottom, the basement is always at the bottom. And I have negative 3 here. So question is, 2 numbers multiply gave you 2. Same numbers add gave you negative 3. What could these 2 numbers be? B, the change you want to see. Somebody's suggesting 3 and negative 1. Another person suggesting negative 2 and negative 1. Let's try them out. If it's 3 times negative 1, it's going to be 3 at the top. So that's too big. That's going to be too big. So maybe I could do. Maybe I could use the other suggestion, which is negative 2 and negative 2 and negative 1. Let's try that. Negative 2, negative 1. If I multiply them out, I'm going to get a 2. That's a happy face at the top. If I added them, negative 2 minus 1, that's negative 3. That's also a happy face at the bottom. Awesome. So this means I'm ready because A is 1. That means you're ready to circle these and claim them as your factors. X minus 2, X minus 1. Okay. X minus 2, X minus 1. Now I'm going to come here and replace them with that. So I'm going to put x minus 2 and x minus 1. I have a question for you here. Do we have the identical denominator? Am I looking at the same denominator between these two fractions, rational expressions? No, we're not. We're missing something. So if you guys remember the fraction example that we started with, if you're missing something, what do you have to do? Does anybody remember? Exactly, you have to multiply by that something that you're missing. So if I'm looking at the left here, I am missing x minus 2. Do you see that? I'm missing x minus 2. So I have to compensate for it by multiplying top and bottom by x minus 2. X minus 2. Give myself more room here. X minus 2. Top and bottom. Don't forget that. Top and bottom. How about this side here? What do you think is missing here? I have to compensate for to have this kind of a big enough picture frame to contain all my factors. What is missing on this side here? Can somebody tell me? Come on, you guys, focus. What's missing on this side that I have to multiply? Yep, it is x plus 1. So I have to have x plus 1 here as well, x plus 1. And obviously you have to do it on top and bottom, the denominator and the numerator as well. Okay. Do I have a similar denominators now? Do I have a common denominator? Do I have a common denominator? Only one person says, only two says yes. Say yes. Come on. Yes, we do. And you could look here, Armani, you could see beautifully here. You have big enough. That's too big. I know, but it's okay. So you have x minus 2, x plus 1, x minus 1. By the way, it doesn't matter how you arrange them. As long as you have all three of them, you should be fine. So at the top, I have, be patient with me because we're going to multiply out. So we've got binomial, means 2 items times 2 items, like bicycle. 2 items times 2 items, and you could use the box. You could use, if you guys remember, box. You could use foil to distribute. I'm sorry, foil to multiply them out. You could use also distribution. It's up to you. I'm going to use the box. So I'll come here and do my work on this side. So x minus 2, x minus 2, and then x plus 3. So I'll go down here and put some work. Oops, that's way too far. I'm going to do some work over here. Just give myself more room for work. This right side I use for work. So I have x minus 2 times x plus 3. I'm going to use the box. So it's up to you which method you're going to use, but I'm going to use the box. X minus 2, x plus 3. X times x is x squared, minus 2 x's. I've got 3x, and I've got negative 6. Negative 6. So basically I've got x squared. Once I do too many of these boxes, I could actually simplify within the box. This guy could be simplified with this guy. So basically I'm saying 3x minus 2x, which is just 1x. So x squared plus 1x minus 6. That's what I get at the top here. So x squared plus x minus 6. How about this one here? Well, this one is pretty simple. 2 times that, right? Just distribute. So plus 2x. If this is a negative sign, by the way, make sure that you have a negative, carry the negative to the problem as well. But this was a plus, so we're good. 2x times 2, or times 2, like this. And then obviously here I'm going to collect like terms. So x squared, well, there's nothing like x squared here. So that's a unique x squared by itself. I've got x here, and I've got 2 x's here. So if I could combine them, that would be good. These items here, these 2 terms. So that's going to be 3 x's, right? That's plus 3x. And I've got negative 6 and negative 6. And also I've got the 2. So that's a negative 4. What is this divided by? Well, this is divided by this humongous denominator. Okay, before I, this is it. That's the solution. Unless if I could, can somebody diamond this for us? X squared plus 3x minus 4? Can somebody diamond x squared plus 3x minus 4? Let's see if we could come up with something here, if that is going to help us. X squared plus 3x minus 4. Could a champion, because we do have a lot of you here, which is all of you are champions, can you try to diamond this, see if we could come up with some factors? X squared plus 3x minus 4. Okay. Do you guys like... let me see if I could share that with you. You remember this one here? So you could erase what you have and try this one here. X squared plus 3x minus 4. Let's see if I could see some or all of you participate. I'm expecting all of you to participate in this. Negative 4 and plus 1. Okay, according to a couple of you, I see some are giving me these here. Some are saying x minus 4 and x plus 1. Let me see if that is actually true. Let's confirm this one. 4x times x squared, x times 1, that's 1x, minus 4x's. Are these switched? Minus 4x's. That's a negative 4. So minus 4x's. I would check again. Is that right? Negative 3, negative... yeah, well, I would check this again. Because if I multiplied x times x squared, x times 1, that's 1x. So x squared plus x. And then I have a negative 4x. And then I have a negative 4. So everything is fine except now I have negative 3x, not positive 3x. So I gotta be very careful with that one. So is that even factorable? Is that factorable? Negative. Who's trying this here? Negative. What if? Okay, let's try to diamond this together. Okay, I'm gonna diamond this. We will try to diamond this. X. So hold on. X squared plus 3x minus 4. So I've got negative 4 at the top, and I've got 3. And you suggested negative 4 and 1. That works at the top, but doesn't work at the bottom. So what if we have it like this? Can I say 4 times negative? That's going to give me the top. 4 minus 1 is going to give you the bottom. Guess what? This looks good. So all what you have to do now is x minus 4. I'm sorry, x plus 4. I'm talking about this here. These here. So x plus 4. That's a factor. And also x minus 1. That's a 4 here. And that's exactly what I'm going to have. So when I have x plus 4 times x minus 1, yep, divided by x minus 2, x plus 1, x minus 1. And in this case, I could just simply do what? What do you think I should do here? What could I simplify? What would my Fruit Ninja do here? Yellow. I'm sorry. Let me share me. It's not sharing my screen with you. I will take this and that, and this is going to simplify with this, and then finally I will end up with basically I will end up with equals 2, and I'm going to erase this here. I have x plus 4 divided by x minus 2 and x plus 1. Okay, that's going to be the final story on this problem here. All right, with this I'm going to conclude our lesson. You guys are awesome. I will see you next time.